Hello students, Strite here again. Here we're looking at practice problems for section 10.5 on hydrates. As always, you should have already completed these and be checking your work now. Number 35, we've got to give us the percentage of the cerium iodide and the percentage of water, and then we want to come up with a hydrate. Remember, a hydrate, you should have figured out by now, is just a ionic compound or crystalline compound that has water molecules attached to it. If we heat this thing up, then the water will dissipate and we get what we call an anhydrous compound. But the work here was very similar to much of the work we've been doing. We think of percents, we just switch them to the grams. So we got 76.3 grams of the cerium iodide. And we've got 23.7 grams of the water. Assuming we have 100 grams of the compound, then we take the percents. Then we change each of them into moles. And we've done a lot of calculating molar masses now, so by now it shouldn't be a problem. The cerium iodide's molar mass ends up being 520.82 grams in 1 mole. You can disable space on here. I'm not going to write in the compound names. You should always write these in though. And water is 1 mole is 18.0148. And if you don't have quite as many decimal places as I do, that would be okay. Grams divide out to grams, grams divide out to grams. And we do a little division. And for the cerium iodide, I got 0.1465. It would be moles of cerium iodide. And down here we got 1.316 moles of the H2O. We divide by the smaller one. On here, that smaller one should always be the compound, not the water. Then 0.1465. And then when we divide those, we get 1 and 9. So that means then we got 1 mole of the cerium iodide for every 9 moles of water. And then we just write out the formula is CeI3 dot 9 H2Os. Another one, same basic problem. We got 62.9 grams, in this case cobalt nitrate. And 1 mole of the cobalt nitrate is 182.941 grams. Grams divide out to grams, and that leaves us with 0.348 moles of the cobalt nitrate. Water, 37.1 grams of H2O. Here you shouldn't have needed to recalculate the water because you just did it on the preceding one. And we got the 18.0148. If you memorize that one, wouldn't be bad. Memorize it. 18.02 should be sufficient, or 18.01. And that gives us 2.059. Again, divide by the smaller one. Divide by the smaller one. And we get 1 up here again. That's what we should always get there. And dividing the other one, we get 6. So that would be 1 of the cobalt nitrate dot 6H2O. Name of this, if we named it, would be cobalt nitrate. Cobalt 2 nitrate. Let's write that name out. Cobalt 2 nitrate. Oops. Lowercase n would be better. Nitrate. 6 would be hexahydrate. So you also need to know how to name these, even though the question didn't ask for that. Thought I'd put this one in here for you. Now this one got one little extra step because they told us we have 14.25% water by mass. We don't know how much lead acetate. Easy to figure out. All we got to do is take 100 minus 14.25, which gives us 87.75. So we have 87.75 grams of the lead acetate. We want to change that into moles, and I know 1 mole is, we calculate, looking at our periodic table, doing all the calculations, 325.2874. Do our division and we get 0.2636. Then we had 14.25% of the water, so 14.25 grams of water. And we get to use the same molar mass there again, which was the 18.01. 0.148 grams. Grams divide out to grams. Forgot to divide those out up here. Forgot to write grams. And then we need to divide those. And we get 0.7910. And we're going to divide them both by the smaller one. 0.2636. Didn't leave myself much room there. 2636. Resulting in a 1 up here and a 3 down here. So our formula is Pb C2H3O2 2 dot 3 H2Os. And 38 brings it a little different. This is something like we might do in the lab. We have a 14.77 gram sample of the hydrate, and we heat it to drive off all the water. And when we're left, we have 9.79. This would be the anhydrous version of it. So to figure out how much water we had, we'd take the 17.44 minus the 9.79, gives us 7.2 This will be the grams of the water. The 9.79 would be the anhydrous version of it. This is the hydrate. And we go through all the same routine. We take this time we got the grams, and the grams. So we just do 9.79 grams of zinc sulfate. We want to change that into moles. So 1 mole is 161. And our periodic table, calculating it out, 0.436 grams. Do a little division, we get a nice tiny little number, 0.06064. And that would be moles of the zinc sulfate. I'm not going to write that out. You ought to always write out as much as you possibly can here, and as we're limited on space, sometimes I leave a few things out. Then we do the 7.65 grams of the water, 1 mole, and one more time I hadn't changed, 18.0148 grams. The grams divide out to grams, and we're left with 0.4247 moles of water. Divide by the smaller one, and this time the water never should be the smaller one on these. When we're doing some of the other stuff like finding empirical formula, very similar work, any of them could end up being the smaller one. And then we get a 1 and a 7, which gives us ZnSO4 dot 7 H2Os. So there's a little work we've done with hydrates. So that's it for now. Next time, next group of practice problems will be a little bit, let's covering all of Chapter 10, Practice Problems 10R. So till that time, straight here.